Let's jump in. What exactly is a 3D scanner? In simple terms, it's a device that captures the shape and size of a physical object and transforms it into a digital 3D model. Think of it as a sophisticated camera, but instead of just capturing color and texture, it also records depth and spatial information. Imagine being able to make a perfect, detailed digital copy of any real-world object, no matter how intricate its design. This opens up a world of possibilities, from replicating historical artifacts to creating custom-fitted parts for machinery. It's not just a photo or a flat image, but a fully realized 3D model that you can spin around, examine from every angle, modify, 3D print, or even integrate into a video game or animation. The level of detail is astounding. 3D scanning achieves this incredible feat using various technologies, including structured light, lasers, or even just a series of carefully taken photographs, a process known as photogrammetry. Each method has its strengths and is suited to different applications. The scanner meticulously captures data from every conceivable angle, piecing together a comprehensive digital representation of the object. This data is then processed and refined to build a precise and accurate digital clone. This technology is a true game-changer, revolutionizing workflows for makers, artists, engineers, designers, and even medical professionals. Its versatility makes it an indispensable tool across diverse fields. In the movie industry, for example, painstakingly crafted tiny models are scanned with incredible precision to become the basis for massive, awe-inspiring spaceships and futuristic vehicles on the big screen. The same technology brings terrifying movie monsters and fantastical creatures to life with stunning realism. The level of detail achievable is simply breathtaking. Factories are now using 3D scanners extensively for quality control purposes, ensuring that manufactured products meet the highest standards of accuracy and consistency. This meticulous scanning process helps in ensuring that every single part produced is virtually identical to the original design, minimizing errors and maximizing efficiency. In the medical field, doctors are using 3D scanners to scan various body parts, enabling the creation of perfectly fitted custom prosthetics that offer enhanced comfort and functionality for patients. This technology also plays a crucial role in the development of custom medical implants tailored to the unique anatomical needs of each individual patient. Museums are leveraging 3D scanning to create digital archives of invaluable artifacts, ensuring their preservation for future generations and allowing researchers worldwide to study them in detail. Furthermore, 3D scanning aids in the delicate process of restoring damaged historical objects, providing a precise blueprint for reconstruction and conservation efforts. Makers and hobbyists are using scanners to replicate broken parts, allowing them to 3D print replacements and breathe new life into vintage machines and cherished objects. Artists are also pushing the boundaries of creativity by using 3D scanning to create unique and personalized custom art pieces, blending the physical and digital realms in exciting new ways. In essence, 3D scanning acts as a powerful bridge, seamlessly connecting the physical and digital worlds, enabling us to interact with objects in entirely new and innovative ways. By unlocking the potential to capture, replicate, and manipulate physical objects in the digital space, 3D scanning opens up a universe of endless creative possibilities and transformative applications across countless industries. Not all 3D scanners are the same, each has its specialty. Laser triangulation is for fine details on small objects like jewelry or tiny models. Structured light projects patterns for fast, accurate scans of faces or furniture. Photogrammetry uses regular cameras and lots of photos, great for big objects like cars or buildings. Time-of-flight scanners use laser pulses to map huge spaces like factories or city blocks. Each method has strengths choose based on your object's size and detail. The right tool makes all the difference. That's the secret to pro-level scanning. 3D scanners, these incredible devices are rapidly changing how we interact with the physical world. But have you ever stopped to wonder, how do these scanners actually work? What's the science that allows them to capture the shape and form of objects with such precision? One common method is laser triangulation. This technique relies on projecting a laser beam onto the object. The scanner, equipped with a camera, observes the laser dot from a different angle. Laser triangulation forms a triangle between the scanner, camera, and laser dot. With the known distance between the camera and the laser source, and the angle at which the camera sees the dot, trigonometry does the rest. It calculates the 3D coordinates of that single point with remarkable accuracy, Another fascinating approach is structured light. Instead of a single laser dot, structured light projects a grid. The camera sees how it warps, revealing the object's shape instantly. The way the grid deforms as it hits the surface provides a wealth of information about the object's contours. Then there's photogrammetry, a technique that leverages the power of photography. Photogrammetry finds matching points across many photos, using parallax to build a 3D model. Just like our eyes use the slight difference in perspective between them to perceive depth, photogrammetry uses the varying viewpoints of multiple photos. Time-of-flight scanners take a different tack. Time-of-flight sends out a laser pulse, times its return, and calculates distance. Like a super-fast echo. The scanner measures the time it takes for the pulse to bounce back, and from that, it determines the distance to the object. Each method collects millions of points to create a digital point cloud. These points represent the surface of the scanned object, each with its own X, Y, and Z coordinates. The result? A detailed 3D map of your object or environment. This map can be used for a variety of purposes, from creating virtual models to reverse engineering physical objects. The tech is complex, involving lasers, cameras, and sophisticated algorithms, but the outcome is simple: a digital twin of the real world. That's the magic behind every scan. It's a blend of physics, mathematics, and engineering that allows us to capture the world around us in stunning detail. Now let's see what you can do with those files. The possibilities are truly endless. So, you've completed your 3D scan. What happens next? After the scanning process is finalized, the data needs to be saved in a format that your computer can understand and that 3D software can utilize. This is where file formats come into play. The scanner processes the physical object into a digital representation, ready to be used in a variety of applications, from 3D printing to virtual reality. The result is a 3D file, usually STL or OBJ. These are two of the most common file formats you'll encounter when working with 3D models. Each format has its own strengths and is suited for different purposes. Understanding the differences between them is crucial for choosing the right one for your project. STL files use a mesh of triangles to describe an object's surface. Think of it as approximating a curved surface with many small flat triangles. The more triangles, the smoother and more detailed the final model will appear. This makes STL files perfect for 3D printing, where the shape is the most important factor, but they don't include any information about color or texture. The focus is purely on the geometry of the object. OBJ files are more advanced and versatile. They store not only the geometry of the object but can also include color and texture maps, allowing for much more visually rich and detailed models. This opens up possibilities for realistic rendering and complex visual effects. So, want a simple, easily printable part without any need for color or complex surface details? Use STL. It's the go-to choice for rapid prototyping and functional parts. But if you need a full-color model with intricate surface details for games, VR experiences, or high-quality visualizations, then go with OBJ. It's the better choice for visually stunning and immersive applications. Keep in mind that OBJ files often come with extra files for textures and material properties. This makes them ideal for creating realistic digital models that closely resemble real-world objects, capturing every nuance of their appearance. In a way, STL is like the blueprint of a house, defining its structure, while OBJ is like the fully furnished and painted model, complete with all the details. Ultimately, the best choice depends on your project's specific needs and the intended use of the 3D model. Regardless of which you choose, both formats are widely supported and considered universal in the 3D world, ensuring compatibility across different software and platforms. And that's how your physical scan is transformed into a versatile digital asset, ready to be used in countless creative and practical applications. Great scans start with good prep. Dull shiny objects with matte spray and use soft, even lighting. Calibrate your scanner for accuracy. Scan from every angle, coverage is key. The software shows what's missing as you go. After scanning, align and mesh the data to form a solid model. Clean up holes and stray bits for a watertight mesh. Trim away unwanted parts like the turntable. Export as STL or OBJ, and your model is ready for printing, editing, or sharing. A little care at each step makes a huge difference in the final result. 3D scanning isn't always smooth sailing. Shiny, reflective, or transparent objects confuse scanners. Matte spray helps. Photogrammetry struggles with plain or featureless surfaces. Add stickers or patterns for reference. Fine textures like hair are tough. Expect some loss of detail. Lighting matters. Avoid harsh shadows. Use soft, even light. Busy backgrounds can trick the scanner. Keep it simple. Every scanner has resolution limits. Match your tool to your project. Noise and small errors are common. Clean up in post-processing. Expect some trial and error, but don't get discouraged. With practice, you'll get pro-quality scans. The future of 3D scanning is incredibly bright, filled with possibilities we're only beginning to imagine. Soon we'll be able to scan entire rooms with ease and precision. Imagine scanning entire parks, bringing the outdoors into virtual worlds. Just think about the potential for the metaverse and VR experiences. In medicine, real-time scans will guide surgeons with unparalleled accuracy. They'll be aided by digital overlays providing crucial information. Digital twins, live, updating models will become commonplace. This technology will revolutionize industries, from engines all the way to entire cities. Soon, scanners will be seamlessly built into our phones, ultimately making 3D capture as easy and intuitive as snapping a photo. We'll scan objects for shopping, precise measurement, and even create custom products instantly with ease. Indeed, 3D scanning is rapidly becoming an indispensable tool for everyone. Prepare yourselves because the digital world is about to get a whole lot more real and immersive.